haven't done a video in a bit, but just this weekend, VS Code released their newest version 1.101, and it had in it a really cool update. They added support for MCP prompts, resources, and sampling, which to my knowledge now makes VS Code the first of the major MCP clients that actually supports the entirety of the protocol. And this is super exciting to me because if you've been a part of the MCP story for a little while, you're definitely familiar with tools. Cursor, Windsurf, VS Code with Copilot originally, they've all embraced the idea of tools. Claude Desktop is another one, where you can create these MCP servers. And what they do is they allow an LLM to interact with other systems, the outside world, if you will. But none of them were really embracing the full protocol. The protocol is a lot more than tools. And with VS Code being the first one to jump in the fray, I thought this was super exciting and I wanted to kind of hack around a bit and see what we can do. So if you're not familiar with MCP, MCP is the Model Context Protocol. Think of it as an API for LLMs. And the big consumers of this, the MCP clients that are very common, if you're an engineer, the most common ones you're using are built into your IDE, whether that's Windsurf or Cursor or VS Code. So the one part of the protocol they've all been using from the beginning is a tool call. So the way that effectively works is when your client boots up, in my case VS Code, it makes a call out to any MCP servers it's connected to. And GitHub Context is the name of the one I made up for the sake of this demo. That MCP server responds back with all the things it can do effectively. So for most of these, that's just been its list of tools. Then when VS Code makes a call out to the LLM model itself, in my case for this demo, that's GPT-4o, it includes alongside its prompt, its system prompt, its context, it includes the list of tools it can call. So if GPT-4o then looks at the problem it has to solve and determines that it would be valuable to use a tool, it responds back to the MCP client with the name of the tool it would like to call and the arguments it would like to call it with. The MCP client then calls out to the MCP server with that payload. The MCP server processes it, does whatever it needs to do, returns a response back again to the MCP client, and then the MCP client sends that response over to the model for the model's final analysis. I mean, it's possible this could loop for a bit. The model might look at the tool and decide it needs to call another. This can go on for a bit. So what are the other ones we just mentioned? We just saw resources, we just saw prompts, and we just saw sampling. So resources are effectively very, very similar to tools. It actually moves in the same flow. The difference is you can kind of think of resources a little bit as read-only tools. I don't have any of those in this demo because I think there's a lot to break down about all of this, but that's actually been one of the aspects that I don't think I fully understand how well to use resources yet. So I want to dig around a little bit more into that. The parts that I'm really excited about are prompts and sampling that just came out. So the different way prompts works, prompts is the simpler of the two. Same structure happens when the MCP client connects to the MCP server, it asks for a list of prompts. And this time, nothing goes back to the MCP server. It actually just stays in the client. And now the client just has these prompts and you can use them effectively like autocomplete to make up a prompt that you're then going to send off to the model. It's a really cool way for the owners of MCP servers to show examples and to provide better context for how to use their tools. Sampling is a whole nother thing entirely. And if you've ever asked an LLM about sampling, unfortunately, it is almost guaranteed to hallucinate because sampling for a lot of us means something like A/B testing. Not at all what it means here in the MCP world. So in sampling, it's effectively a reversal of the tool call. So sampling always will happen within the context of a tool call as far as I'm aware. So to go back to kind of our tool call example, client called out to the server to get the list of tools. The server responded back with them. Client sent a message to the model. The model said, please make a tool call. The client called out to the server and said, this is the tool call. And now here's where it might change. If this tool call uses sampling, a very interesting extra step can happen where instead of responding with an answer, the server actually responds back to the client and says, actually, I would like you to call the model again and do something for me. Then the client reaches back out to the model, and effectively what's like you can think of it as almost a separate thread here, because it is not part of the original conversation. It does not have context. It does not have the tools we already sent it. It doesn't have the conversation history. It is just a single discrete call out to the LLM. The LLM responds with the response of that. The client sends it back up to the MCP server, and now the MCP server is theoretically ready to respond with the result of its tool call. So the example that a lot of folks go to with this is maybe you want to summarize some results. You don't just want to dump a ton of information back to the model. So I spent a lot of time wondering how this could be used, and I think it's one of those things that's easier to look at than it is to actually explain it. So I'm going to jump into a little demo that I created. This is VS Code Copilot updated to the latest version, and what I have here is I have my GitHub Context MCP server installed through just locally on my machine through standard input-output, and it's just going to run through UV. And then what I have checked out here is this is actually the repo for Inertia Rails. Because I wanted Inertia Rails is a project I've been working on for a long time, and it's a cool repo with a ton of history, with a bunch of different contributors, and it can be easy to get lost in these repos sometimes. So for an example, this is part of the Inertia Rails' renderer, and this is kind of a strange piece of code. Why are we casting this to JSON and sending it in as a JSON argument? And maybe I forgot why it's there. So what this server I created does is I can click on this bit, and one of Copilot's options is I'm going to add the selection to the chat. Now, what I want to do is I want this to use my GitHub Context MCP server, which does have tools. If we hop back over here to settings, we can see that there is one tool in this server, but there's also a prompt, which is really exciting because a prompt can actually help us guide that. So the way VS Code handles them is if I just hit a /MCP dot the name of my MCP dot the name of my prompt will show up here, and I can just select it. And what does it do? It fills in my prompt with whatever was in there. So now I can just go ahead and hit enter. And it's automatically going to start running, and it's giving updates. And let's see what it comes back with. This is always the fun of making LLM calls. What is our latency going to be like on a live demo? There we go. Awesome. So we got this exact piece of code, the PR it was introduced in, and then a quick summary of the change and the conversation that happened. And one of the things that's really cool about this is if we look at this PR, so the link is good, you can see at a glance that some of the information it had did not come from the PR description. It came from subsequent comments on the PR, which I think is pretty cool. So what happened here, and why does this make me so excited about sampling? So what's actually interesting is we can see where the sampling took place, but let's just look at what actually happened. Let's hop into the code. So this is the MCP server itself. It has a prompt. This was the exact prompt that you saw get automatically inserted into the actual call that was made from Copilot. And one of the things it does that I think is cool is it gives context for what to do to kind of guide the LLM for how to summarize it. And it's very opinionated. It's very specific. It does not want the LLM to make its own choice about a tool. It just comes right out and says, use this tool. So a little bit of guidance about how to summarize it, a little bit of input guidance to say like, hey, if the user hasn't selected any code, let's not just let them try to summarize a whole file. I don't know how that would go. But then we hop down into the tool. And what the tool does is it's called find GitHub context. And it takes the following arguments here. So it's looking for the absolute path of the repo, the relative path of the file, the line numbers that were selected, and then the actual code that was selected. So then it's going to use the first of the cool things for these new MCP clients, of which VS Code is paving the way. I very, very much hope that Cursor and Windsurf follow. What it's going to do is it's going to report progress, which is how if you saw that go past, you actually got to see a little bit of updates as it said what was going on. It happened very, very quick though. It's going to run a git blame, which is going to use a combination of my local repos. And then it's going to actually make this call out to GitHub. All of this is 100% normal tool calling. We ran some local commands. We called out to a third-party API. Nothing super special has happened yet until we get to these calls, the filter relevant PRs and analyze PRs, because both of these calls actually use context. So let's hop in. And the simpler of the two of them, but they both follow the exact same pattern, is this analyze PRs. So what is actually happening here? We are going through our list of PRs that have already been filtered. So we made another LLM call to filter down to the most relevant ones. And we said, let's go through these PRs that were returned from GitHub, and let's make an LLM call to summarize it. And then let's just return these summaries. And what's really awesome is if you look at this, and I'll push up this code to GitHub, we aren't set up to call an LLM. There is no LLM actually being literally used by this MCP server. We are sampling, which means we are using the client's LLM to make our own LLM calls. Just a super cool pattern if you want to be able to publish things that need an LLM, but you don't want to be responsible for that downstream LLM. Maybe you want your users to be in control of which LLM is actually called. That is an option here. In this case, we don't try to use that, but sample does accept that. Oh, I don't have my type hinting here. I do have my type hinting. I'll just throw it in here so we can see what it looks like. Sample actually allows you to even put down, as you can see, a model preference. So in this case, I didn't give one. And if you don't give a model preference, it's just going to use the same model by default that the original call was made from. But that's really a choice the client makes. That's at least how VSCode handles it. And you can do other things to handle it. You can check a little bit of configs, a max token, which is possibly a good idea because you are spending the client's tokens at this point. So you want to try to be polite upstream. You can add a system prompt, you can add messages, so you can have a little bit of a history going here. You can make a relatively full-featured LLM call. And then it makes these calls. There could be several PRs at this point. So it batches them all together and awaits them all at once, and it returns that analysis. Now, the question I imagine a lot of folks are going to have is, why didn't you just return all the PRs to the LLM? And there's a couple reasons for that. And that makes me think this sampling is such a powerful pattern. But the big two reasons that make it powerful for me is, number one, we're returning much more actionable information to the LLM. So this is super important because imagine that diff, this example was that diff only had a single line, but imagine you're trying to get the diff of 10 lines. And almost all of them were released in one PR, but maybe 3 or 4 of the lines have a different PR where a linter ran on them or something unrelated. If you just dump all of that PR information back to the LLM is probably going to do a decent job at it, but you have to use the word probably a lot more. You're going to lose determinism. You're going to lose control over how you get to frame the results back from your own tool. The other thing you're going to do is you're going to clutter up the context history for your users. As anybody who has used these tools knows, the longer you carry on a conversation, the worse your results tend to get. I know myself, I'm in the habit of pretty much clicking new chat in Copilot or Cursor every single time it does one discrete task for me. I like to move on very quick, fresh history, fresh context. We all know LLMs perform better when they have less to consider. So this is a really nice way to do less processing in bulk. The other nice thing that we got to do with this is we got to run all of these calls effectively in parallel because we sent all of them out and just awaited the whole group of them, as opposed to sending all of them back to the LLM and making it reason about this whole thing. So it's not just an output boost, it's a performance boost from a latency sense as well. What else can sampling do? I honestly don't know. I'm really excited to see how this goes. Like I said, one of the reasons why sampling hasn't been super popular is because virtually no clients have supported it. So like I said, I'm very, very excited that VSCode was the first one to jump into this and allow us this kind of really, really powerful additional 2 features. And I just talked about sampling for several minutes, so I don't want to get lost in how cool prompting is. The idea that I can give instructions. And just to give a quick example, in this one, the prompt doesn't take any inputs, but this is pretty cool too, is you can actually give inputs as well. If you say MCP server, let's add a prompt, and we just say say hello, and we can, let's add an argument to this one. That's kind of a weird thing to say as a prompt. My name is name. And excuse the EasyCater Dev Wrapping MCP. That is the company I work for, and an awesome place if you are interested in this kind of stuff, because we are just waist deep in it or I guess we're neck deep in it right now. We are absolutely trying to be on the cutting edge of these AI techniques like MCP. So to give this quick example of, now we have a prompt that actually requires input, and we can go back over here. I'm going to restart because this is standard IO. I'm going to open up a new chat. I'm going to delete that or put in there. And now we should see, yep, we see another prompt. This one has a description, which is nice that we actually put one in there. And if we select this prompt, we actually get another prompt up here for text. So I can just go ahead and say Brandon, and there's the prompts already filled in. So, like I said, really excited about this. Really excited. I hope that Windsurf and Cursor very quickly follow in Copilot's footsteps here. And in the meantime, this is a heck of a boost for Copilot. Super exciting time for MCP. Really nice, really excited to see what the community comes up with for what the full protocol can really do beyond tools.